The next speaker is Eric Vicenti. He's a good friend of mine, actually. We've worked a lot together on React navigation. And over the last year, every time I've been around him, it's been difficult to hear him talk nonstop about this exact thing that he's about to talk about, because he's just so interested in it, and he will never stop talking about it. So it's good that now he can share it with other people, and you can all learn about this actually rather interesting project that he's working on. So yeah, here's Eric.
Hello, App.js Conf. Woo! I'm excited to be here. All right, my name is Eric Vicenti, and I work at a company called Ono Food Co., where we use React on the server, React Native, and on the browser. And I've come to the conclusion that building apps across all these platforms is really difficult. Building apps across the full stack is really difficult. And we can make it dramatically easier to build apps across the full stack. And I think we need an opinionated framework that helps tell the full story. Because React Native is incredible when it comes to getting up and running really quickly. You can use create React Native app, or rather Expo init or React Native init, and start building really quickly, and even start going to the web using the exact same skill set using the React Native styles. Now, this helps us get a long way, but React Native still doesn't solve everything. Every time we build an application, we're still left to manage navigation to ourselves, and we're still left to manage data handling to ourselves. And for a long time, I've been working on the navigation side of the problem in the React Native community. But today, I'm not going to be talking about navigation. Today, I'm going to be starting to talk about a data handling idea that I have about how we can move forward in a more cohesive fashion. So let's start thinking about what it's like when we just have a front end, right, before our application gets so complicated. Now, a front end itself isn't very useful when you actually want to go deploy it to customers, because you need to save data somewhere. So you're usually going to need to involve some sort of server to save the data. And that server is often a program running in some service that itself isn't stateful. It actually needs to go write the disk to maybe some other service like Postgres, like a database, or the server could just write it to disk. Regardless, this app is seen as our client. And this is going to be either our browser or our React Native app. And in reality, we have a bunch of clients. And when we scale our application, we're going to have a bunch of servers potentially as well, all talking to the same database. But there are a lot of complexities that arise from this sort of design. And this is incredibly popular. But just a couple of examples, right? So we can send a client out into the world, and we think it's a perfectly good client, but it turns out evil. Clients can be manipulated and impersonated, so we need to protect our servers here so that they're not writing bad things to the database if a client becomes corrupt. OK, so that's a mess. What else? What is the client usually doing with the database? It's asking for data, but also asking to observe the data. So a client can ask, let me see this record A and continue to watch it. If another client goes and changes that same record, somehow our database needs to propagate that change to the original client, even though they may be talking to different servers. All right, this is a pain, but hang on, it's going to get worse, because a client could actually have a shaky connection to the internet, right? It can be a mobile app. So a client can go offline temporarily, and it will still want to continue writing to its app. You still want to have a really great, friendly offline experience where the user can continue interacting with their data. But other people may be interacting with the data while they're online at the same time. And this is all fine until you come back online, and all of a sudden you need to synchronize. What are you going to do then? OK, I don't know. These are not super easy problems, but it's going to get worse one more time, actually. Because a client is often looking at computed data on top of the source data that's being written. It's not actually looking at the exact data that someone is writing to. It's looking at some aggregation or some computation on top of that. And it's very frequent that a lot of clients are going to be looking at these computations. So if any of the source data winds up changing, then this computation somehow needs to get propagated to all of the clients who are looking at the computation, so that their views remain up to date. Okay, well, this is tricky because it makes you wonder, where is this computation actually happening? Who's really doing this computation of the derived data? Right? If you do it on the client, maybe you can get a really great user experience, actually. Maybe this is really desirable if you do it on the client, because then you have an offline-friendly application where you change some data and the rest of your app reflects those changes. Well, that's good. You could also do it on the servers, though, because you don't want to trust that client to really do the computed data, because, again, it could be corrupt. So your servers could do this computation. Well, those servers, if you have lots of servers doing the same computation, it could get expensive. So maybe the solution is to delegate this to the database. Time to brush up on our SQL, go write some virtualized tables and some stored procedures. I'm just kidding. But I don't really know what the solution is here. It's hard to tell which one of these things should be doing the computation. So I look at this mess, and I see all these related concerns when it comes to data. I get this impression that, and I can't help but wonder, where is the database really, right? Of course, we have it labeled in this diagram. It's right there. That's the thing that's actually writing to disk. But the servers also seem to have to do a lot with the data. They need to know how to subscribe to it, enforce the permissions, do computations. But then again, the clients also are going to need to be able to do offline changes to that same data. So I think the database truly lives on the full stack, and it would be silly for us to assume otherwise. And I don't think there's going to be any one-size-fits-all solution. These problems are application-specific, and they're not trivial. So rather than having one library that I wish I could just present and say, look, this is the one solution to all of these problems, I don't think that's going to be available. So instead, I want a framework, I want a toolkit that I can use to go solve these problems on an application-specific basis. OK, so we've been looking at these building blocks, and I think they're total shit. Because if you think about it, you can actually be running your client on the server sometimes if you want to do server rendering. If you want to save data locally inside of a React Native app or inside of the browser, then you kind of need a database on the client. So I think we need to throw away these building blocks and take a breath of fresh air, take a step back, and think about what it would be like if you just had your head in the clouds for a year after you quit Facebook and decided to go just work on this open source project for a while. And anyways, that's what I did, and I wound up creating AvenCloud. And AvenCloud is a full-stack framework for building data-based applications with JavaScript, especially with React, as you might expect. So the advantage here is I had the chance to rethink things from first principles. So take everything that I had learned in the past and bring it together into one sort of more clean path forward when it comes to managing data on the full stack. So let's take a look at one of those first principles. I've come to realize that basically all applications and all databases have essentially two types of data. Forgive me for oversimplifying, but you might agree when you realize that the data is either data that never changes and data that changes, right? OK, so for the data that never changes, let's go ahead and call these blocks, right? They're blocks of data, the real data. For the data that changes, let's just keep in mind references to these blocks, and these are going to be called documents. So the blocks are real JSON that we're actually going to wind up saving to disk, and the docs are just references to these blocks. All right. So blocks are going to be identified by checksum, and this is really handy because it means that anybody holding the data can independently agree on an ID without having to transmit the data back and forth. And docs are identified by a name, which is just really handy when you're programming. So blocks, you can load once and know that you've got them for sure. You can even verify it by taking a checksum to make sure it matches the ID. Now, a doc, you're going to want to subscribe to it if you want to know what your current data is. OK, and this is really critical for the cache. This is a huge problem in computer science, right? Cache invalidation. So blocks, you can always cache, and you should never cache a doc if you can help it. But when you go offline, you still want to keep a doc around so that you can show something to the user. OK, so we've talked a little bit about this fluffy stuff. Let's talk about where we're actually going to save this. And well, first, let's take a look at an example doc and an example block. Here we have a doc named message, and it refers to the hello world block. And if we want to change the message, we're going to upload a new block and switch the reference over. All right, but where are we actually going to save this? We're going to need somewhere to write this down somewhere. We're going to need to save it to disk at the end of the day. So let's talk about the storage sources. Now, a common storage source is going to be like the Postgres storage source. It's actually going to connect to a Postgres service, and it's going to allow you to have several JavaScript servers in front of it. But for development, you might just want to use something simpler, like a file system-based storage system. And on the React Native clients or in the browser, you might have a different storage source that's client-side. Anyways, that's all. Every storage source is going to have the same interface, which we're going to call for now the source interface. It allows you to save data to it and observe data that's inside of it. OK, and this source interface is going to come in very handy. But we haven't saved anything over the network yet, and that's ultimately what we're trying to do. So we can use a couple of modules to proxy a source over the network. Let's have a source server and a source client. That's going to allow us to do this proxying. Now, we've been talking a little bit about this. We've got a lot of slides, but I think we're going to need to go into a little bit of code as well, right? So this is what our architecture looks like so far. We have a storage source, and we're passing it into a server, and then we're able to consume that same source from the client because we're proxying it over HTTP and WebSockets. All right. Let's jump into a little bit of code. I can show you what it's like to create a storage source. Here we're creating a file system-based storage source. We're setting up a domain because I'm kind of prematurely optimizing for multi-tenancy. But in this case, the domain is what you'd expect. It's just like the big bucket for all of your data and all of your users and everything. So here we're going to create a storage source that's a file system-based storage source. We have to wait for it to start up. Here we could also potentially connect to a Postgres storage source, and we would wait for it to connect. And Postgres storage sources support multiple domains. OK, next up. We can go ahead and serve this over the network. This is kind of pseudocode. It's not really going to work right now, but this is what it would look like if we wanted to just serve this source on port 8888. From the client, if we wanted to consume that same source, it would be here. We say the authority is basically a poorly named host, local host 8088. This is going to be how we want to access it. And use SSL during development would be false. Anyways, this is the client. And now we have a source that we can consume on the client that is really proxied to our server. And yeah, obviously this is in the same file, so it's not actually on the client, but we'll get there. OK. Next up, let's talk about the cloud client. Now, this is a little different from the networking client, because this is going to be the thing that's actually going to be going and observing the data from our database. It's going to hydrate the data for us and allow us to change it optimistically offline. OK. And it's going to connect to our JavaScript application, and it's going to be taking in a source. So what you're most likely going to want to do is you're going to want to put it on the client, on your React app, and it'll be talking to the network like this. So really quickly, let me just show you what it's like to create a client. A client is created in the context of a domain. So here's a client. And we're going to pass in the storage source and tell it which domain of data that we wanted to access. So then we can access a bunch of different useful things on the client, but we'll get to that in a second. All right, let's talk about the protected source, because we actually are doing something pretty silly here. We're just exposing our data source blindly over the network. So right now, anybody could be putting data into our database and deleting stuff and doing all sorts of bad things. So we're going to need a way to sort of protect our sources, and we can implement that with a protected source. And it's kind of like a module that takes in some data, it talks to the database, and it exposes some data, but it exposes a slightly more advanced protocol that allows you to authenticate with it. And the authentication is the process of identifying the user, either with some custom protocol or end with a session. And permissions is going to be restricting the user to only access certain things. So I kind of have to gloss over the authentication stuff because I don't have any time. So here's how it's going to fit into your database, and it's going to make sure that you're no longer sort of illegally accessing the storage source directly from the network. Cool. So we've got kind of a full stack here. Now, if we have any server-side rendering fans in the house, which I sure hope we do, you'll notice that we're doing something a little silly if we wanted to server render, which is that between our app and our actual data source, we have this big network thing with HTTP and WebSockets. And that could actually be running on the same server. So what would that look like? Well, we can actually take the client and the app and just put it up there as well. So we've got that going on in the code as well. We're doing a little bit of server rendering, even though it's not really mature yet because of server-side suspense still kind of being something we're waiting on. But basically, we have this high-level thing that's able to run our server. We provide our source, which in this case is the protected source. And here we provide we set up our server, and we're providing our app. Oh, here, let me zoom in so you can actually see what's going on. Here we're providing the app as well as the source. Now this is the protected source, which I forgot to show you a second ago. So let's show you how we set up the protected source. It's a little bit involved, but you don't have to do all of this if you don't want all these different authentication mechanisms. So here we have an authentication provider for email, and then this is the little thing that actually does sending the email via SendGrid. We have the same thing here going with SMS and Twilio. So we have SMS and email login. Here we have a root login. So this is basically a hard-coded password. Literally, PW is the root password to this, so please don't hack this. We're creating our protected data source here. This is the thing that's actually going to be performing authentication, and this is what we're going to want to pass downstream so that anyone can access this, but still have to go through the permissions, the authentications and permissions. So here we're providing the source, which would be the storage source, and we've got our various providers. Here there's a little utility that helps put the permissions. Here we're putting permissions that are going to be used in the demo, but you don't have to worry too much about that. Or not right now, because yeah, the protected source is still something that's heavily under development. Okay, so we're coming along here. Now let's think about, because we've got these clients that have access to a generic source, we have a lot of flexibility. From the client, we don't really have to worry about the database being remote or the database being local. The database could be proxied through several network sources for all we care. All we have to think about is, like, we are the client, we are the app, and we're talking to the client. The client talks to the cloud or something like that. Like, we don't really know. We don't care. So from the client's perspective, what's going on? Say you want to access some data. You might want to access, like, a message, and the server will respond and say, oh, this is the ID of the message. Here's the value. Message is hello. You might also want to observe. You could say, let me know when the message changes, and the server says, oh, here's the new ID. Here's the new ID. Message is changing. Okay. So let's take a look at what that might look like in the code. We've got a few different APIs that you can use, but I want to show you the kind of nice APIs, right? So here's going to be one of the sort of simpler APIs that you have. You can use Cloud to get access to the client from the context. So when you see Cloud here, let me zoom in. When you see Cloud, just think of this as the client. We're going to be accessing message doc, which is getting a doc off of our client, and we're going to pass this doc to our two different children. So let's take a look at message title. Message title gets in this doc, which is, again, we got it from our client, and we pass it to use cloud value. Now, obviously, you can see we're using hooks. Sorry, I didn't mean to do that. But use cloud value is basically allowing you to observe this message doc. So whenever the value of this message doc changes, this component will re-render with the latest title. How about when we set the title? That should be up here. So here we have a text input. We have access to the message doc. We literally just do put. And this is an async thing, so we should probably catch this. But yeah, so now you get the idea. It's pretty easy to use this client from the React, especially once you have the ability to get things from context. And then you can just pass things around through props. This is a real app. It should work on web and mobile. We'll see if it does. Goodbye. OK, does it change on React Native? Not today. All right. We've got things warmed up now after the demo gods have been sleeping. All right. So oh yeah. It's just a little bit of code to get clients, synchronization between client and server. Of course, this is a very bare bones demo, but let's see where we can take it from here. OK, now let's talk about writes. Now, writes get interesting when multiple clients are actually trying to write the same thing. So what if two clients are writing to this message, and they try to write it at the same time? Both writes will wind up succeeding. Now, in this case, in this simple app, that's actually not really a bug. Two people were trying to set the message, and the last person to set the message set the message. This is fine. So last write wins works fine for simple cases, but for any sort of complicated data structure, it'll fail miserably. Now, as a simple example of a complicated data structure, let's talk about a list. And maybe let's talk about a to-do list, because we're non-creative programmers who just uses the basic example. So say the to-do list is, you ask the server for the to-do list, and the server says that the list is A, just A. Now, both clients are going to want to add something to the to-do list. The first client says, oh, here, let me write AB. The second client says, let me write AC. You can see where this is going. The first client succeeds, and that's not really a problem. But if the second client succeeds, we've lost B. This is really bad. This is a disaster case, because we've told the first client that, look, you managed to write B, and now it's gone. So we need to find something a little bit better for more complicated data structures. OK, so what if we had the ability to put transactionally, which is to request of your source, let me put this thing if the current thing is this block ID, right? So how this would work is the first client would say, let me put to-dos A/B, or A comma B, if the current list is A. And the second client would do the same with C. So obviously, in this case, the first client is going to succeed. The second client is going to fail because the server's like, nah, it's changed. Now this client is going to be like, oh, bummer, I had a race condition. Let me go merge it, go ahead, add this C to the new list, and put it and let that succeed. Now, this is a client-side merge, and actually sometimes this is desirable, because sometimes you want to ask your user that, hey, look, while you were offline, or you were changing something while somebody else was changing something, how would you like to proceed? Would you like to write your changes and squash theirs, or what would you like to do? So sometimes this is what you want. But I think we should do better. We should be able to have fire and forget transactions that you can send to your server, and something that your client code can assume that is safe to resend later without squishing out other people's changes that they've written to the database. So what would a transaction look like? Well, instead of saving the full list to the database inside of our doc, what if our doc pointed to the most recent action? So to-do action, it says, you might ask the server, what is the most recent action? The server would say, in this case, oh, here, the most recent action was to add A, and this action is on a nothing. So it's on no previous action. So basically, that means we're at the beginning of our list. So now we know, hey, A is the whole list. OK, and if we want to go and put B to the server, but we don't really know whether or not, or actually we're going to be trying to put C to the server, and we don't know if B has been put or not, let's go ahead and tell the server to just put this transaction to the server, and the server will say, oh, I actually wound up putting this thing. And this thing refers to whatever it actually was on the server. So you can see here that the client thought the server would be putting the action on 287. But actually, the server came back and said, oh, actually, I put the action on C81. So at this point, the client, who has optimistically added C locally because they're able to just run that action through the reducer, that client is now able to go say, oh, look, I missed this action, C81, go download it, and put it back into the list. So now the client knows the true order of things, which is one of the really powerful things of using actions and reducers, is because the actions can be reordered safely. Cool. So we've gone and made a really big problem for ourselves. At the beginning of the session, when a new client arrives, it wants to know, what is the to-do list? So it's going to go ahead and ask, what is the to-do action? The server's like, oh, yeah, you were adding C. And then you're going to be like, onto what? And then what was that? Oh, you were adding B onto what? So finally, you get the full list after going back and forth. And as you can imagine, what this means is that the longer you use your app, the slower it gets, because you have to load more and more actions up front. This is really bad. So what we'd like to be able to do is we'd like to be able to say, yo, server, just tell me the result of this action once you've passed it through the reducer all those times. And of course, the server is going to be like, what? What's a reducer? So at this point, we need to go back to the drawing board and figure out what we can put on the server that's actually going to be able to run this calculation. Because right now, all of these calculations are happening on the client. So what if we took a chunk of the client and actually ran it on the server, so that way we could get server functions? And that's the eval client. Like, this is the coolest module. I saved the best for last, because this is the thing that allows you to define functions against your database, server side. And not only can you define a function and get the result of it, but you can subscribe to the result of it. So the database will automatically notify you when any of the derived data has changed. But it won't waste your time unless the computed value is actually changing. So this is pretty powerful. And in order to sort of use this to handle our reducer, it's not even really using the full power of what the eval client can do. But it is one of the cooler examples, is actually having a server-side reducer. So let's go ahead and take a look at the next example, where we're actually going to put this into action. So the eval client, by the way, is going to fit in like this, between our storage source and our protected source. So it's going to have access to the full data, but we also need to make sure that we're letting in access to the eval client as we want to. So in this case, I'll just show you. We're doing put permission on task actions by task reducer. So this is how we're kind of letting the permissions through in this case. OK, so let's take a look at the next example. Actually, let's just go ahead and I'm going to skip an example because we're going to get straight to the fun stuff. OK, so this is our application where it's actually deferring the reducer to the server for the initial load. OK. So it's a to-do list that seems kind of relevant right now. In fact, I might want to go even rename the title as like launch checklist. OK. Oh boy. OK, so let's see. Does it work? Maybe finish talk. OK. Well, that was supposed to synchronize over here. All right. So let's see. Something about the website. Oh, website's looking pretty good, actually. Let's just do that. Something about putting code on GitHub. I think that's supposed to be a step. OK. That's looking pretty good. What else? I guess we're going to go to Twitter. We have a new Twitter account. Check that out. Oh, no, it looks like something about the session or something. Twitter. OK, and all right, just one more thing to do. OK, so now let's take a quick look at what it looks like on the client to sort of get that ideal reducer experience. The client will ask, what is the value via the reducer? The server comes and delivers the initial state right away. You want to send an action to the server to do something? You send an action to the server to do something. You optimistically apply it locally. And then depending on what the server says, you're able to go fill in the missing actions. From the other client, you're going to get the initial action that way. You're going to go ahead and observe the action. And then as any additional actions happen, you're going to go and pass them through the reducer. So every client is going to be doing the reducing at the same time if they're observing a certain thing. Now, I think this is a really powerful concept. And I kind of think of this as Redux for the full stack. It's really cool because it allows you to think of things in the way that you're already thinking about them in terms of just what actions to dispatch and how to define your state as a function of the most recent action. So this is really cool because we're already used to this model, but because of this, we're able to run this on the full stack. Because we're able to reorder these actions, this is a really good conflict resolution mechanism. So I think this concept is pretty exciting, but it relies on some sort of principles that we had to sort of reinvent or rediscover, like immutability, keeping track of that throughout our stack on the database, not just on the server side. Throughout our stack, we're going to keep in mind the immutability. We're going to use source interfaces to pipe together different modules. Kind of like how Redux has middleware, we can go ahead and assemble our application out of the constituent components that we think is most appropriate. And this is really just a draft. Like, I can't wait to see all the different ways people are able to wire together their sources and compose them in pretty unimaginable ways. So this is stuff I've been pretty excited about. I call this project Avencloud, and this is going to be launched today, as you can see, under the liberal open source Apache 2 license. And it's ready for explorers. I'm ready for people to come give it a try, open some issues, hopefully send in some pull requests. It's not quite ready for production. I'm going to be putting it into production in the next couple of months. And it's not quite ready for beginners, but both of these things are goals. And it kind of takes me back to the original mission. I want to make apps dramatically easier to build. And this is super important to me because a few reasons. I think, for one, we need better apps in this world. We all suffer when we use bad software. It's incredibly frustrating. And also, I think we need better diversity in the world of software engineering, better representation. It's really frustrating to not see as many people as we should out here. So in order to sort of do this, we need to lower the barrier to entry to get more people building great software. So to do that, we can and we will make great apps dramatically easier to build. So if you want to follow along with this mission, this is the mission of Aven. You can go ahead and follow along on our new website and on Twitter. And I really want to thank you for being part of this incredible community, and I can't wait to invite you to take part in this mission of going ahead and making apps incredibly easy to build. Thank you.